We are now looking at exercise 14.6, congruency proofs, question 8. In this question we have an isosceles triangle ABC in which we are told that sides AB and AC are equal. We're also told that CL is perpendicular to AB, hence we have a right angle there. And we're also told that BM is perpendicular to AC, hence we have a right angle there at M. The first part of this question is to prove that triangle BLC is congruent to triangle CMB. Now we can see that those two triangles are overlapping, so it's actually good practice to draw the two triangles separately. So I'm going to draw those two triangles separately. And then you can see a lot clearly, you can see those triangles a lot more clearly if you do that. So there's my first triangle, and the second triangle is just coming in now. I'll try and make them a little bit smaller so that they, so that you can see them on the screen, that they're not overlapping. Okay, that'll do. It's not perfect, but it's okay. Okay, so we have to prove that triangle BLC is congruent to triangle CMB. Now the first thing that we can see is that we have this angle down here. So because it's an isosceles triangle and AB equals AC, then we know that angle ABC is equal to angle ACB. Okay, so we're going to say that first because they are base angles of an isosceles triangle. So angle ABC, there we have, equals angle ACB. Look, you can call it angle LBC and angle MCB, or you can call it angle ABC and angle ACB. It doesn't matter, but you need to say that they are base angles of isosceles triangle and that AB equals AC. Reason being that the two angles that we've spoke about are opposite sides AB and AC. The next thing that we can see is that both triangles have a right angle. So we can say that angle BLC is equal to angle CMB, and the reason for that, they're both 90 degrees, and that is, the reason is that CL is perpendicular to AB and BM is perpendicular to AC. So you can write that down next. The last thing that we can see is when the actual triangles are sitting on top of each other, we can see this, is that BC is a common side. Now you can see on the two individual side triangles drawn that you've got side BC and side BC, so they are the same side. So the third reason in our proof is that BC is a common side. Thus we have our three pieces of information for our congruency test. So we've got a right angle there. We know that this other angle, this angle LB or ABC is equal to angle ACB. That's two angles, and we had the base side. So that's two angles and a side, so they're congruent therefore by AAS. Okay, now the second part of the question. Now we have to now prove that triangle BLN is congruent to triangle CMN. Now often when there might be this second part of the question, you can use information gained from the first part of the question. Now, because we know that triangle BLC is congruent to triangle CMB, we can see that LB equals MC because they're corresponding sides of congruent triangles. But BL and MC are also sides of these new triangles that we're trying to prove are congruent. So that would be the first statement that we would like to say. We should probably talk about which triangles we're talking about. So we should say in triangle LBN, sorry, I haven't got my triangle symbol. Oh, yes, I do. So in triangle, I'm just going to say that up here. So in triangle BLN and triangle CMN, we know that, first bit of information, that BL equals CM, and that's because they are matching sides of congruent triangles that were proven in part 1. We also know that in these two triangles, we've also got a right angle in each triangle as well, and that again is because CL is perpendicular to AB and that BM is perpendicular to AC, so we can write that down. So far we've got a side in each of those triangles and the right angle. We're now looking for a third piece of information. We do have here vertically opposite angles, so angle LNB equals angle MNC because they're vertically opposite angles, so we can put that in there too. And that's our three pieces of information. We've got two angles and a side, so therefore those two triangles will be congruent by AAS. When you have a right angle triangle, don't necessarily think that that the proof will be, the reason for the proof will be right angle hypotenuse side, because in this case we actually have two angles, as I'm just showing you now, and we have one side. Okay, so we've proven that those two triangles are congruent, and now for part C, hence show that LN equals MN. We can see that LN and MN are actually corresponding or matching sides of the two congruent triangles that we just were looking at. So they are equal because they are matching sides of congruent triangles. And that ends this question.